Recording started, and let me turn this off. It's making a little noise. And we'll start. And if you need to go over a little, we can go over.
Okay.
So
sounds good.
Don't worry about it. 10-15 minutes is not a big deal.
Okay. I think we should be good, but let's see how it goes.
Okay. Okay, I'm going to start in just a second here.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the DBA Fundamentals Virtual Chapter meeting for, actually it's our second one for July, but third if you count the one down under. Today's presentation is entitled SQL Server Performance Monitoring and Baselining. It's going to be presented by a member of the SQL Server Tiger team, Parikshit Savjani. I hope I pronounced that right, Parik. But anyway, I got a couple of announcements to make first, or a couple of things to go over. Sorry. The deadline for where you really had a big savings for past Summit just passed on the 17th. The next deadline is September the 18th. After that, it goes to full cost of $23.95. I'm sorry, yeah, $23.95. And so you've got about a $350 savings if you use our discount code if you sign up before September the 18th. At this point, you would have probably already started making plans if you're going to attend, and I would highly recommend that you attend. And if you do, please use our code VC15GBQ6. I am sorry, something's wrong with this. Our sponsor is SQL Sentry. They are the makers of the famous tool, the Plan Explorer, that is fantastic. If you want to, if you're in trying to do query tuning of any type, you're going to want to go look at the execution plan, and this is a free download. They will not bother you. You don't have to buy anything. It's a fully functional download that you can use for ever. And they also provide free tuning advice. Let me back up. Went current slide. If you will send questions about your poorly performing queries to answers.sqlperformance.com, they will in turn work on it, send you suggestions, and they'll work with you on it. I'm not sure how far they go as far as, you know, spending weeks with you, but they'll work with you and try to figure out some stuff for you, so you ought to take advantage of that. Past Virtual has lots of virtual chapters. I don't know, probably 60 by now, on practically every topic that you can think of in data, and a lot of the major languages. So go to sqlpass.org/VC and check that out. Here's our sessions coming up. After today, our next one is August the 2nd. Glenn Berry from SQL Skills, famous for the DMV scripts, which are fantastic, will be giving us a presentation on high availability, disaster recovery 101. I'm really looking forward to that because he's so good at what he does. Down under, on August the 9th, there'll be a presentation by John Martin, Securing SQL Server Recommended Practices. And another one down under on September the 12th will be Understanding Backups by Sean McCown. On September the 13th, we'll have a presentation by Bob Pustari. I don't have his name down there. Managing Very Large Databases. That's going to be a really good presentation too. In fact, that's something that we're looking at right now. And then, of course, the next deadline of September the 18th on the code. And as of if you haven't signed up yet, one of the things we do is instead of giving away money every session, we kind of save it up for kind of big giveaways. We're giving away a $500 Amazon gift card, and if you are drawn from the pool of people that use our code. So this session will be recorded, and you can get to our sessions at two locations. You can go directly to our fundamentals.sqlpass.org meeting archive site, or you can go to our YouTube channel and subscribe, and then that way whenever I upload a video, you automatically will know when it's there. Okay. That's everything I think I was going to cover. Oops. Don't. Tariq, can you still hear me?
Yep.
Okay. Apparently that wasn't a problem. I don't know what's happened. Okay. Okay. SQL Saturdays, sorry. If you haven't been to a SQL Saturday, it's like a miniature Pass Summit. It's one full day, free of charge. They'll charge you for a lunch, and that's about it. Or if you don't want to eat lunch there, they don't charge you anything. But sponsors all pay for this. It's free training. And here's the ones coming up. Of course, Columbus just passed, but if you see anything there, I'm going to try to go to the August one. And here's the international ones. So anyway, you can go to SQLSaturday.com to check out if there's any in your area and the dates and times. And you can register at that point. As always, PASS needs volunteers, so they obviously need a better moderator than I am today. But there's lots of different ways that you can help. You can help with local SQL Saturdays. You can help with virtual chapters. Go to SQLpass.org and check out ways that you can be involved. Okay. Ready for Parikh. Parikh is a member, like I said, of the SQL Server Tiger team, and they're a group of people within Microsoft that are tasked with presenting information about different technical aspects of SQL Server. And they do this all the time with large customers and virtual chapters and local chapters, so they're very good at getting out the best information. And if you have questions, please ask the questions. They can get the information to high technical people at Microsoft if they don't have an answer. So Parikh, I'm going to turn it over to you. Let me change the presentation to you.
Sure. Okay.
There you go.
Steve, yep, let me know. You're able to view my screen?
Yes, I can see it good.
Okay, good morning, team. Yep. So today I'm going to talk about SQL Server performance monitoring and baselining. So before doing that, let me quickly introduce myself. My name is Parikshit Savjani, or you could call me Parikh. So I'm one of the program managers with SQL Server Tiger team. So I'm one of the, I would say, newest member of the SQL Server Tiger team. You might have heard from my colleagues in the previous session from Amit, Ajay, we have Bob, Sunil, Pedro, all part of the SQL Server Tiger team. So one of the key important roles of SQL Server Tiger team is focusing on the in-market enhancements to delight our customers. So we are responsible for all the in-market releases, and so now SQL 2016 is in market. So our team works into in-market releases and in-market enhancements of SQL Server. So let me okay. I'm trying to change the slide. Yeah, just give me a minute here. Okay, so a brief introduction about myself. Although I've been new to the SQL Server Tiger team, but not new to Microsoft. I've been 8 years with Microsoft and with SQL Server. I have a couple of books as well, which I have authored. One of them is on BI, SSIS tabular model, and another is on SQL on Azure. I have my personal blog, SQL Server FAQ.net, and we are also pretty active. I don't know if you are following our blogs. It has pretty good stuff, in-depth content in there about the new enhancements we are bringing in SQL Server 2014 SP2, which we just shipped last week on July 11th. And we also had the enhancements on SQL 2016, which was also posted on the blog. So, and SQL releases blog is what we recommend you follow for any announcements on service packs, cumulative updates, which we are releasing. I mean, you would know that cumulative updates are released roughly every 2 months, and service pack, it depends upon the market needs, and depending upon some of the roughly you would say it is somewhere between a year where we release service packs, but it can change, and it is depending upon a number of other things as well. So yeah, so that's about me and SQL Server Tiger team. We are pretty active on Twitter as well, as you would know. So yeah, you can follow us on Twitter there. Okay. Quickly about this session, the core focus of this session is to understand what is SQL Server Performance Baselining, why is it required, understand what scenarios you would target with SQL Server Performance Baselining. Now, this is one term which is used interchangeably, which is SQL Server Monitoring, Performance Baselining, and Alerting. I want you to understand the difference between them. So that is one of the key takeaways which you should understand, because although they go hand in hand and they are interdependent, monitoring, performance baselining, and alerting, but all these three terms are targeting different scenarios. So I think it would help if you have a clarity on when do you need SQL Server Performance Baselining, when do you need monitoring, and what is the use of alerting. So understand what performance baselining means and why is it required. What tools do you have in SQL Server to establish a baseline? Learn how to use the performance baseline tools to understand and troubleshoot performance issues. So that is one key takeaway from this session. And see a performance baselining and monitoring solution which I have developed using SQL Server and SQL Server reporting services. Now this is very subjective, and it depends upon different scenarios. When you talk about performance baselining, it can be used to target various scenarios. The focus of this session would be very generic performance baselining, which you want to capture and monitor. If there are some specific scenarios which you have in your environment, that will be outside the scope. But the solution which I have developed is extensible and can be further be extended. So I will be showing this solution to you, and I will also be sharing it in GitHub. Feel free to use it as is, or you can further add on to it. So if you are good with the SQL Server reporting services, if you are a developer, or you can further contribute to enhancing the monitoring aspect of the solution as well. So I'm going to show you the SQL performance monitoring solution which I have developed, which I've been using with some of my enterprise customers, and you can see and see if it's a good fit for your environment and if you want to leverage it for establishing performance baseline. Okay, so let's quickly move to our first topic, which is why performance baselining. I think the question of power of why is very important. I mean, the other day I was watching a TED talk on why, the power of why. So to understand why we are doing it. So and this is where I said earlier, people tend to use performance baselining interchangeably with monitoring and alerting, but each of these things, each of these terminologies are used to cover different scenarios. So why do you need a performance baselining in your environment? So it is not uncommon for many of you, many of the database administrators who would be getting into a performance troubleshooting, and you get a call one day wherein you are asked to troubleshoot an application or troubleshoot a performance slowness, and the application team comes to you or a business owner comes to you saying, hey, we are experiencing slow performance. The first question is, what do you mean by slow? I mean, define slowness. So, and that's 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 one of the things we need to understand. Performance is relative. So, how slow is slow or how fast is fast? So, a good example. The other day I was talking with a storage vendor from for one of the big enterprises. And in our conversation, somewhere he brought up saying, hey, this response time of 100 milliseconds is normal for us. And for any SQL or database guy like me, you would say, no, that's not true. I mean, I would expect uh, database response time to be less than 15 milliseconds to be to qualify or quantify it to be a good performing disk. And he said, no, that's wrong. So and it took us some time to get into an agreement that, okay, for SQL Server, for a good performing disk to qualify or quantify a disk to be a good performing disk, your performance or the latency should be less than 15 milliseconds. But from a storage guy perspective, they look at the IOPS, they look at the queue length, and for them it doesn't matter what the latency is. So that's where one of the important things as database administrators or as performance engineers in your organization, you need to ensure or understand how fast is fast or how slow is slow. So that's one scenario wherein you would need to establish or you need to have a performance baseline to quantify and qualify whether your server or SQL Server instance is running slow. Now, some of these questions you would ask an application developer or a vendor, and sometimes the application vendor relies on you being a database expert. So again, I don't know which team should be owning this, but I believe there should be a joint partnership, or at least the database administrator should be owning or having the performance baseline for the SQL Server instance. So that's one of the things or one of the places where SQL performance baselining is important. Capacity planning, another scenario wherein if you want to identify hardware requirements for your current workload, the average resource utilization, these questions come often wherein, okay, can you tell me what is a workload? Can you tell me what is the CPU utilization on the server? Is it normal? So, I mean, on a good day, what is the CPU utilization? When the server is performing bad, what is the CPU utilization? And if you are seeing a trend of your the CPU utilization going high or memory utilization going high over a period of time, and you can also correlate with the SQL workload activity, you can say, okay, we might be running out of resources and we might want to add new hardware. So that's another place where you would want to have a performance baseline. Consolidation. Now this is not new in the modern world, wherein you have shadow IT, DevOps model. Within no time you would see your the number of SQL Server instances are all over the place. Every developer, every application team has spin up their own SQL environment, and now when a database team is asked to cover them, they want to make sure generally you would have your database managers who would ask you to work on consolidation to reduce the cost, to reduce the servers in the environment. So consolidation is another area where it is important and critical for you to have a performance baseline to understand what is the workload, what is the resource utilization. Virtualization and migration to cloud, another important aspect. So if when you're moving either, or when you're virtualizing a server, either going to virtual machines or moving to cloud, again, one of the questions as a database administrator or a database consultant, which you would be asked or you're expected to know is how much CPU is required, how much memory is required by the server instance, what is the workload on the SQL Server instance, and based on these numbers, you can estimate what is the VM size required, and in cloud you can further estimate what is going to be the cost of the running a VM per hour, and then you can extrapolate it to get what is the cost of running that server for a year as opposed to buying a physical box. So this is another place or another scenario where it is important and critical for you to understand and have a performance baseline for you to provide those answers to your leadership, to your management, and estimate the cost for them. So that makes it easier when you want to extrapolate or forecast what VM size is required after migration. So now that we understand why performance baselining is required, let's understand what exactly is performance baselining. So performance baselining is nothing but capturing the last known good state metrics, which can be used as a starting point for comparison. Yeah, that's kind of a textbook definition of performance baselining. So you want to make sure that you understand that on a good day, during the peak load, what is an average CPU utilization, average memory utilization, average network I/O, average batch request per second within SQL Server. So that is what we call it as last known good state, which can be used as a starting point for comparison. Now, and this is where is the difference. So in order to establish a performance baseline, you need to have monitoring. The goal of the performance monitoring or baselining should be non-invasive with minimum overhead. So performance monitoring is needed for a number of other things as well. Even for example, when we are troubleshooting from Microsoft, we would ask you to run PSS-Diag, which is a popular tool which we run for troubleshooting. Now, even that is performance monitoring or performance data collection, but that's not meant for baselining. You might also need performance monitoring for alerting. For example, you might want to be alerted when SPN is not registered on a particular SQL box, or when you have non-yielding schedulers reported in the error log. You might want to be alerted for that. For those scenarios also you would need performance monitoring. But here in this case for baselining you also need performance monitoring, but you want to make sure it is non-invasive and with minimum overhead because you want to keep it running throughout throughout the day, throughout the year, throughout the month. So it should be non-invasive. So that's one of the goals of performance monitoring for baselining. Baselining requires capturing the performance matrix on the time dimension. Now, this is where when you're establishing a baseline for SQL Server, it's not just a one-time activity, because as you're running application on SQL Server, as the resource utilization changes every second, your last baseline, I cannot take up the information from last month on let's say 15th and say, okay, this was my performance baseline. That is wrong. See, you can visualize this as a constant moving target, wherein you can't say that, okay, you can't have a static data set and assume that's a performance baseline. Your performance monitoring for capturing the baseline has to be continuous, and you need to measure or visualize the historical data to understand the trend. So it has to be across the time dimension. Every metrics which you captured has to be captured at a regular time interval, and then connect all the dots to understand what is the trend and what is the average utilization. So it's not just one snapshot and you say this is the starting point for comparison. That's not true. It has to be monitored continuously. So and that's the reason historical analysis of performance metrics is useful to understand any anomaly or to predict the future behavior in SQL Server. So that's one of the critical aspect of performance baselining. That is historical analysis of performance matrix to understand any anomaly, what changed, what happened, or to predict the future behavior. So if you're seeing that year on year, month on month, or day on day, you're adding batch requests per second, or if you're adding the CPU utilization is increasing on the server, then you know you can plan ahead in time saying, okay, with the rate at which, or even I think the most common example here is the growth of the database. You would, if you know what data is being added every day, you can accurately predict ahead in time that when your disk space will be exhausted and when do you need to plan for disk. Now you still need an alerting in this case wherein if the free space in the database goes below 10%, send me an alert as a database. So this is a monitoring where you would still need to be alerted, but you still need to be proactive and ensure you highlight it to your management, leadership, or the business owner saying, hey, with the rate at which we're going, we might exhaust the disk at around a year's time. And so this is what baselining will help you. Baselining is more of proactive, alerting is more of a reactive. So that's one of the key difference you need to understand. Both baselining and alerting requires monitoring. So unless you monitor, you don't know what state you are in. But performance baselining will help you to be proactive and plan ahead in time. And can also be used in sometimes in reactive scenarios because you're still capturing the performance matrix and you can detect any anomaly. But primarily it is meant to be for you to be proactive. So that is what is performance baselining and how it is different from alerting. And one of the things we need to take away from this slide is monitoring is required, and it's not just monitoring, it is continuous monitoring across time dimension. And then when you do a data mining or historical analysis of your performance matrix, it will help you to predict the future behavior or to understand any anomaly which has happened in the past. So, okay, so in the context of SQL Server, what tools do we have to establish a performance baseline? So these are primarily the performance monitoring tools which we have in SQL Server. At the ground level, at the very minimum, this is what we all capture in SQL Server: perfmon, dynamic management views, and extended events. So, and again, you might have, there are other tools which are built on top of it, but at the ground level, it's all these three tools. If you have all these three data sets, you would be able to troubleshoot, or you will be able to understand any kind of performance issues or performance state within SQL Server. So even PSS DAG, if you have run in your environment, or if a Microsoft engineer has asked you to run PSS DAG, PSS DAG internally captures performance monitor logs, DMV information, and extended events or profiler, and all of these are collected together and based on a focus scenario which we are trying to troubleshoot. We select specific perfmon counters or specific events in the extended events or profiler to troubleshoot specific scenarios. So so even for establishing a performance baseline, the tools remains the same, which is perfmon, DME, and Xevents. So let's for monitoring resource utilization, what are the perf counters do you have which you need to monitor? So one is, for monitoring the CPU or processor utilization, and these are the counters. I have a detailed explanation in a blog post, which I've provided the link in the slides, which I'll be sharing with you. But let me also describe some of these performance counters. Person processor time is basically your total CPU utilization on the server. Now, because you are monitoring performance baseline for SQL Server, you will also be selecting process, and under process, you also have person processor time, and you would be selecting it for SQL SER VR, which is the SQL Server process. Then you have processor person privilege time. That is the amount of time, amount of the total CPU time which is spent for IOs, network IO, or any kind of privilege mode execution in the CPU. Normally, you should see this value less than 10%. On a good performing server, you should have person privilege time should be less than 10%. If it is not, then there might be some issues which needs to be looked upon. Primarily, you want to make sure your drivers are up to date, your network NIC drivers, firmwares are up to date. So that's one of the common scenarios which we have seen in the past. And further, again, it is important to see in the context of, for SQL Server process, what is the person privilege time? Why are we focusing on SQL Server utilization? Because you want to know if SQL Server, how much percentage of the total CPU time is contributed by SQL Server. So that's the reason you want to make sure you capture, you compare your total CPU utilization and compare it against with the CPU utilization for SQL Server instance on that server. Memory counters. Okay, and before I move to the slide, let me quickly switch on to, if you have not seen perf counters, I'm sure most of you would have, but real quick for anyone who have not seen perf counters in the past. So this is how this is the performance monitor log which is present in your Windows server. You can capture performance monitor logs by using the UI. This is the UI. Or you can use PowerShell, you can use command prompt. There are various ways to capture performance character set. So in this case, I will be adding the counters here to quickly show you what I was talking about. And so this is the person processor time I was talking about, total, and you can also capture at the instance level. And within the process, so if even PSS diag also captures the same perfmon, and there is an XML file by which you can select which counters you want to add in the performance collection. So in process, let me go to process real quick. So in process, I have some problems with my monitor and display, but okay, if you expand process, I don't know, my screen is froze for some reason and I'm not able to select it. But if you expand process, you would have a person processor time, and you would filter by, here you would see all the SQL or all the processes which is running on your server, and you would select person processor time. So this will show you under process for SQL Server what is a person processor time, right? So let me switch to a report mode. So under process, you would have person processor time for SQL Server, and you can also compare it with the total server. So this is the performance monitor, which performance mon log, but I'll show you how do we, in the solution which we've developed, I'll show you how we collect this using PowerShell and use SQL agent to load it into a database. So for memory, we would capture available M bytes on the server, available megabytes, which is how much memory is available on the server. So and you can then from that you can derive how much is the memory utilization on the server. On a good performing server, you would always want more than 1 or 2 GBs available. That's a rule of thumb which you might want to have, but it again depends on every environment, and that's where it is very every environment is different, and that's where you might want to have a baseline to understand what is an available M bytes on a given server for your environment. Memory pages per second process, again, this is for SQL Server, you want to see private bytes, which is the amount of bytes which is committed by SQL Server process. And working set is the portion of the SQL memory bytes which are committed in memory, in your RAM. And this is where if you have lock pages in memory, you would see most of the private bytes committed in the working set. There were scenarios when you don't have lock pages in memory privilege turned on, you would see if there are faulty drivers, if you have other issues on your server, other application can actually cause SQL Server to either trim the memory because if there is a memory pressure, SQL your available memory M bytes goes down, and if available M bytes goes down, your target server memory on the server goes down, and wherein SQL Server is asked to shrink, and you would also see the total server memory going down. So this is what we call it as external memory pressure, wherein SQL Server will start decommitting memory. Now, besides that, previously due to faulty drivers, we also experienced scenarios wherein the SQL Server's working set was getting trimmed. What do we mean by that? SQL, in this case, the SQL Server is not decommitting memory because it's before even it can decommit memory, a driver which is either leaking memory or which needs more memory would ask operating system memory, and it would want to run it on the RAM, and this will cause your SQL Server to go into your page file. So, and that's where your working set memory would be trimmed. So you want your working set to be as close to your private bytes within SQL Server.
Great.
Then we have, yeah.
We have one person that asked the question, and this may not be possible because it may depend, like a lot of IT questions. They want to know if there's a document somewhere or a website or something that basically says this is the healthy range for these particular counters, and what to look for if it's outside of that range.
So yeah, this is precisely why you need a baseline. So a healthy range for some of the counters, yes, and in the blog post which I will share with you, but really to kind of quickly show you the blog post which I'm talking about, I have some of the counters which, so this is my blog post wherein I have talked about some of the performance counters and what is the acceptable range, what do you see is the problem. So I will be sharing this blog post wherein I have some of the numbers for you, but again at the end of the day it all depends, and that's one of the reason why you want to have a performance baseline. These numbers are very subjective. These numbers might be different in a various hardware, operating system combination, various drivers. So there are a lot of variables here. Different hardware, different drivers, different firmware, different operating system, different SanDisk, and all those things will make there is no right answer here. I have some estimates for you in this blog post, some numbers which you can refer. But again, that's one of the reasons you want to capture performance baseline, to see on a healthy environment what is those numbers on a given server, and when something went bad, you can, or when there is an anomaly, you want to go back to those numbers and see what changed. So that's one of the reasons you want to have performance baseline. But I will share this link, and that might give you help give you some answers there, because I have some numbers in there.
Good deal.
Yeah. Okay. So for memory, for SQL Server, we have total server memory, which tells us the current committed memory or current buffer pool memory by SQL Server, and more precisely, it's the buffer pool memory. There can also be memory outside buffer pool, which can be present. And we have target server memory. So target is where SQL Server can go. Target is an indication where the SQL Server memory is healthy and it is growing or it is shrinking. So you would in a easier way, total would follow target. So if a target is higher than total, then total can continue to increase. That is, the SQL Server B pool memory can grow. If total is equal to target, then your SQL Server memory is pretty much, it has hit the max server memory limit and it cannot grow further. If your target is less than total, and I will show you those scenarios as well, in that case, there is an external memory pressure, and your target, when it is less than total, it's telling or signaling your SQL Server saying, hey, you need to shrink memory and you need to decommit pages, and total will again try to follow target and will start decommitting pages and will try to be either equal to or less than target. So this is how I would say total would always follow your total server memory within SQL Server will follow your target server memory. Okay, moving to the next, physical disk, and this is where I think most of you would either be aware of these counters already or familiar with these counters. Disk latency, which is average disk seconds per read, seconds per write. That is how we determine from SQL Server what is the latency of the disk. And now this is not always what your storage vendor would understand, but this is a key counter, a performance matrix for us to understand if after an I/O is posted by SQL Server, and it goes through various layers within operating system, and then within the fiber channel, SCSI channel, and then within the controllers and within the storage or the RAID configuration. But this is what you see from SQL Server, and this is what we understand, or this is what our understanding is for a healthy performing disk. You would always want your latency to be less than 15 milliseconds for a transactional system, or in general for a healthy SQL Server environment. Average disk queue length. Now this number, I don't have a real number for this. It depends on various hardware configuration and various different environments you have, and this is very subjective. So, and this is where performance baseline will tell you what is an average disk queue length which you observe, and on a bad day, what is the average disk queue length which was observed, and you can then try to correlate some things. Disk bytes per second. This helps. This information is what your storage team is looking for. How much is your workload? Because they want to know how much bytes you are going to throw at your disk per second, and they can then go back and correlate with the disk throughput which is supported, or the IOPS which can be supported by disk. So this is the number which your storage team is looking for. So disk bytes per second and average disk bytes per transfer, which is the depth of a single I/O operation. Now in SQL Server, you can have I/O operations ranging from 4 MB up to a few megabytes. Normally your data page I/O would be between 4 KB to 64 KB, but your backups can go higher depending upon the max transfer size and other different things which is going on. So average disk bytes per transfer helps there. And again, from process, you want to filter out from SQL Server to understand what is the I/O operations, what is the I/O operations per second for the physical disk. Network I/O, again, network interface, bytes received per second, bytes sent per second, and the output queue length. And it again depends upon the adapters which you have and the bandwidth supported by the NIC cards. But this is the number which you want to keep an eye on, and if there are any changes on the network layer, like NIC teaming added, or you change some configuration, these numbers as they change will give you some some information about there is something which has changed on the network layer, or if the traffic itself has changed, or if you've added database mirroring or always on or other things. Now again, as I mentioned before, these are the counters. I'm not targeting any specific scenario. Like if you have always on in there, you might want to have a different set of counters also added to this particular list. If you are troubleshooting, or if you want to have, if you have service broker in your environment, you might have a different set of performance monitor counters also added to the list. But in general, for resource utilization, these are the performance monitor counters which I would capture unless I'm troubleshooting any specific scenario. And that's where again I'm, like I mentioned before, performance baselining is not always performance troubleshooting. You can use some of the performance monitoring, but to establish a baseline, you don't need a lot of counters unless you're targeting any specific scenario. So monitoring SQL Server activity. From a SQL Server side, what are the counters which are important? From SQL Server side, you have SQL batch requests per second, which gives you the SQL throughput, or the amount of workload which is thrown at the SQL Server from the application layer. This is a key matrix to understand the throughput of SQL Server, and what if you are hitting a limit, or if you're not able to scale, you might want to keep an eye on this number to understand what that number is for your environment. SQL, so out of the batch requests which are submitted, how many will go for compilation and how many will go for recompilation? Compilation tells you that if you have a more of an ad hoc workload which is not parameterized, which you're using more of a ad hoc SQL queries, that's what application is firing. Or if you see a lot of SQL recompilations per second, then you might be using stored procedures in your environment which are going for recompilations for a number of reasons. So that is where SQL recompilations will help you understand the type of workload which is being going to SQL Server, and if it's changing. SQL DM exec requests, DM exec sessions, and DM exec connections. Now, this is where I would not get into the details for monitoring or establishing a baseline. I would continuously have an aggregated snapshot captured very frequently, like for sys.dm exec request, as you know, tells me what are the number of active worker threads executing a batch within SQL Server. So you might have like 500 connections, but out of them only 100 would be firing an active batch and would have a worker thread associated with them. So a periodic snapshot of SQL DM exec request will tell you how many concurrent batch requests are being executed by SQL Server, and how many worker threads are involved in that. Sys.dm exec connections again will tell you or give you information about the user connections which are present in your environment, and periodic snapshot would tell you if application is using connection pooling, you would see this number pretty stable, but if this connections are going high, then they are not using connection pooling, and there is something which is causing the number of user connections to increase. It might be a legitimate high workload end of month scenario, or it can be something different. So that's sys.dm exec request. SQL waits. So if somebody asks me or somebody tells me that if my SQL server is running slow, then one of the key things you might want to look at is the wait, what it is waiting on, what is it waiting on, and what is the top wait on the SQL server. So again, from perfmon counter, we have SQL server wait statistics and sys.dm OS waiting task. If you take periodic snapshots, you can go back in time, and if you are doing kind of a post-mortem analysis of what happened yesterday, 3 o'clock, what was the top waits, you can refer it. You can refer to the snapshot of sys.dm OS waiting task. Now, sys.dm OS wait starts also is a good number, but it's a cumulative number. So if somebody tells me, if I see a top wait as CX packet, and if somebody tells me yesterday 3 o'clock we experienced an issue, I can say that this is possibly CX packet, but I'm not confident because at that point in time, I don't know what was the top weight. Since the time SQL Server started, we saw CX packet. So that number can be misleading sometimes because it's a cumulative number, but it would still give you I mean, you can still try to correlate it with the other data points which you have to get an understanding of what is the common top weights on the SQL Server environment. Database index fragmentation, this is another activity which you want to monitor, how frequently indexes are being used, how frequently they are getting fragmented, what is the average seek, scans, and all those information you can get it from these three DMVs. Monitoring from SQL Server system health. So starting SQL 2008, yeah, it was SQL Server 2008, and then we further enhanced it in SQL 2012. We have a system health X event session, which is like a black box recorder in your SQL instance running constantly and capturing some of the important metrics which helps us or gives us a lot of information of what might be going wrong in a particular SQL Server environment. So so one of the key things is query processing health, which tells me how many worker threads are getting created, how many ideal workers are there, and what is the max worker thread in your environment. And if there are any deadlocks in your environment, that is also reported and captured in system health session. Lock and latch waits. So if there is a latch wait more than 15 seconds, if there are locks which is held for more than 30 seconds, IO latch timeout, long IO status, they are all captured in system health session. Fatal issues, deadlock schedulers, non-yielding schedulers, access violations, out of memory errors, corrupt pages status, all of that is also captured in system health session. And if there is any kind of security errors, login failures, you would also see them captured in the system health session. So it's already available. The data is already there within and being captured out of the box within SQL Server. All you have to do is make sure you extract that data from the XCL file and be able to visualize it in a format which makes it easier for you to understand and consume that data to understand what was going wrong. So in the solution which we have developed, I will also show the report which is available to monitor this out of the box without any issue, and you can identify what went wrong or what are the common things you observed on a particular SQL Server environment. So now one of the things with systems health session monitoring is it only has, just to minimize the default and to minimize the disk space requirement, it has only 4 files and each file is 5 MB. Now sometimes this is where you would lose the historical data which is being captured because it is rolled over and it is overwritten, and that's where you might want to increase the system health XCL retention. So here is a script which you can run on your server, your SQL instance, to increase the retention for system health session by increasing the number of files and by increasing the max file size there. So this will, and again it depends on your environment, but if you can afford to have a larger file space or a larger storage in there, I would want to go ahead and increase that to go back in time to identify what are the issues which happened, because system health gives you a lot of information without even adding any additional captures in place. So I think it makes sense to change these defaults if you have sufficient storage to capture them. So now that we understand to establish a performance baseline and to monitor an environment, we need performance monitor capture, we need DMV information, we need to extract information from system health session. So now let's bring them all together and build a solution out of it, and that's what I'll be showing you with the demo. So before we go there, one of the goals for the solution which I had in mind when I was working on it was it should be non-invasive, it should be scalable, So non-invasive, I think we've already talked about it, because on a SQL Server production environment, you don't want to be running something like a profiler or any additional events, which can be an overhead for the system itself. So it should be non-invasive. It should be scalable. For example, if you are having a monitoring solution, and as you add a new instances in your environment, you 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 if you start seeing problems in your monitoring solution itself, wherein there are locking, latching, then the solution is not scalable. So the solution, whatever we are looking for, should be scalable. It should be performant, because it doesn't make sense that if in a crisis or if you want a report, you click on a report and it takes forever, like a couple of hours to bring it back. I mean, it won't make sense for you to have a solution which is not performant. And it should be low cost, because you want to use as much as the out-of-the-box tools or the tools which are available within the Microsoft ecosystem, and you do not have to rely on any external solution there. So those were the goals. Now, this is how your typical monitoring solution architecture would look like. Normally, you would have a capture performance data and upload it to a central monitoring server, and from there you would pull out the information. One of the things what we found was that this system becomes a bottleneck and doesn't scale, and as you add new instances in your environment, it can also it becomes less performant. So going back to the previous goals which I discussed, my focus was to develop a solution, to come up with a solution which is much more scalable. So, and that's where so for this, I had also worked with one of my friends and colleague with my previous customer environment, so Kate Tokerman and a good friend Raghu, for this. So this is where we developed or had a local databases on each of the SQL Server instance. So rather than having or capturing the data on a central server, we make a capture on a local server or local instance on every SQL Server instance. So you create a database called DBA local for your own local capture for that specific instance. And you can have your SQL resource utilization, performance data, weight statistics captured locally, so you don't involve any network traffic, you don't upload it on the network server or a central consolidated server. You would rather keep it local within that SQL instance. However, you still need or want to use, now this is optional, but it is still recommended that you have a monitoring server wherein you capture all the version information, the backup information, because if that server goes down, you need to go back to some central server to look for what was the SQL Server instance, where was the backup files, and what is the physical layout, and all those things you still want to capture from the central monitoring server. But the solution which I'm talking about, which is focused on performance capture, that information is captured locally on every SQL instance. And you have a SSRS portal or SSRS reporting installation on the central server, and wherein all the reports are deployed, and these reports will then query each of the local instances and give you performance monitor data. So without any delay, let me quickly show you the performance monitor data which I have. So this is my central server. So in fact, my laptop is my central server wherein I have deployed. So if you see my URL, this is where my performance monitoring data is captured. Okay, first. Okay, let me go to this URL. So this is my, if you see the URL, so this is my central, you can think about my central reporting server. This is the report which I'm talking about, and this is where these are number of reports. I will start with SQL Performance Dashboard. which is my central dashboard. Now this is where I can go to any SQL instance, and in my reports I am building dynamic connection string. So based on whatever SQL instance name you provide, you will be dynamically be connected to that specific SQL instance, and within that it will be the connection string will look for DBA underscore local. So here I want to see the performance data for my desktop machine and SQL Server on the desktop server, and I have the last 6 months of data. That's my retention for this particular solution. This tells me the performance utilization. This is the last point in time snapshot of the performance utilization. So what was the last value of performance utilization on this particular, what was the user workload, which in other words is the batch request per second, available memory on the server, and the disk latency. This gives me all the information about my server, which is what is the server name, what is the instance name, logical processor, build, memory, whether it's clustered, SQL version, and what is the SQL start time, when was it last started. Now here, unfortunately, I started this collection. I didn't realize I had rebuilt my server, so I lost my previous collection there. So I only have performance data as of yesterday, but otherwise you would see a trend for last 6 months. I have some screenshots which I will show you how the data looks like, but this is just because I have only data as of yesterday, so you don't see any data points here. But I still have, I have another, so these are all drill down reports wherein you can click on the day and the report will be routed to the daily report. So this is what I call it as your daily trend report, wherein it aggregates the information for every day and it gives you the data, aggregated data for the last 6 months. But you can further drill down to that specific day, and that's where it navigates to the daily report. So let me also take you there. So let me go to the daily report and let me connect to the same server again. And this is the data as of today, but I can always go back. So this is the data which was observed today, but let me go and look at the data yesterday. So if you see here, yesterday there was some anomaly, like somewhere between 9:45 and 10 o'clock, I saw a couple of spikes. The CPU utilization, so this is the total processor utilization of the server, and out of that, this is the SQL utilization. So, and this is where you can correlate whether SQL is the cause or is it the victim, and or if there is something else running outside SQL Server. So if this yellow line would not have followed the same trend as your total CPU utilization, that tells me there is an external agent also running in there. And you would also see that, okay, there is only, although you see the same trend, but SQL is only contributing to 50%. So there is something else also running in that environment. This tells me the user connection at that point in time. So I also see that there was a spike in user connection at that point in time. This tells me the active session request trend. So at that point in time, what was the most common wait types on the server? So I saw there were a number of threads which were in the suspended state between 9 between 9 o'clock, 9:07 or 9:17 to 9:37. This tells me that on this particular server instance, I had average of like the highest wait type was async network IO, and I also saw a resource semaphore wait type, which tells me that I had a lot of ad hoc workload query, and the compilation time went really high in that case. And you might be able to relate this with the SQL compilation spike as well. If you see the SQL compilation spike, which happened after 10:55, and you would also see the resource semaphore wait also happened at the same time. This is where the available memory also went down, and this is where it tells me the disk latency. This is the 15 millisecond bar which I'm looking for, and you see that there was a spike at the same time, so my disk latency was also poor at that point in time. Now this is what I mentioned was drill down report. So I can further click on, like if I see an available memory was going down, let me click on that, and it takes me to another report. Now this is where I clearly see the the downward trend. If you see here, the available memory on the server went down. The target server memory also went down. So if you see here, the red line is the target server memory, and when the available memory server went down, the target went down. Now in this case, the total server memory was never equal to target. So there is still room for total server memory to grow within SQL Server. So SQL Server, that's the reason, was still growing. But imagine if the SQL would if already would have been using the total memory or the target memory, SQL would also had to shrink in this case. In this case, you see a reverse trend because SQL was not I just restarted the SQL Server for testing, and the SQL never used all of the memory. So it was still growing while the new connections and the new workload were added, um, uh, but you saw the available memory went down, and the target was also going down to to respond to the external memory pressure here. The paid life expectancy, free pages, checkpoint pages, this is what you would see for memory. And again, these are the counters which you would want to establish the baseline. So here you see there is a lot of queries which are in the suspended mode, and I see like there are 100 threads which were in suspended mode, and all of my wait type at that point in time is async network IO. So this is where I would say if you look at sys.dmos wait stats, you would see a lot of IO threads accumulated, which tells me, okay, what is going wrong in general. But if you want to go back to a specific point in time across time dimension, this is where I'm taking regular snapshots of sys.dm exact requests, which tells me on which database I had most number of suspended thread and what was the highest weight on these queries. So, and besides this, so this is I can also click on. I think I already clicked on the user session details. So I had suspended 289 suspended threads, and 289 were in suspended mode. Here, most of the weight was on resource semaphore. So this is the query compilation issue which I was talking about. Besides this, I also have a database storage report to quickly show you what's on your what drives, what is the free space on the drive, what is the percentage free space, percentage use space. It tells you what is the files which are in use, if you can shrink them or if you can grow them, or what is the free space used available in your environment. And there is also an index fragmentation report which tells you for any database what is the fragmentation on that particular server. So the best part of now, you can have this report in Power BI or various other reporting tools as well. One of the reason I am inclined towards reporting services, it allows me to export the the report in PDF format. So if I were to click on the report here, and if I were to export this in PDF format, and with reporting services you can also have email subscription, so the report can be delivered to you. So let me show this. So this is the report which I have it in the PDF format, which takes a screenshot of it and which shows you how the data looks like. So yeah, this is a PDF format which you can send it to your application team, or which you can send it to your manager or whoever wants to learn what's going on, what is the state of, or what is the workload in your SQL Server environment. So, yeah.
Obviously, everybody likes this a lot, and we're getting a lot of questions. Is this going to be available? Or are you going to have a step-by-step guide on? Oh, good. I want to play with it.
Yeah,
It's really cool.
Yeah, so I would be sharing all of this in GitHub. And I wanted to give this to the community, and you can further fork into it and add new stuff to it. You can leverage this as it is. So you can do all sort of things which you want. So I will also go through this and quickly show you other stuff for system health session. So for system health also, like I did some tests yesterday. So let me go to AdventureWorks DBA local. This is where I had. Yesterday I was running some out of memory or running some O-stress to get the out of memory errors. Let me take an hour of capture. Okay, I want to make sure I show you system health also. This was developed by Denzel, if you know Denzel from SQL Cat team. So now if you see here, if on yesterday, now this report directly queries your system health X event capture, loads it into the local database, again your DBA local where you would load it, and I'll show you what things are involved here. You can clearly see yesterday between 12 and this is where we saw a resource semaphore wait types. Now this is where I want to see if there was blocking, what was the top waits on that server, and here you would see the top waits on the server environment, which is non-preemptive waits. Let me also go back and look at the blocked query. Okay, let us first look at the warning. So if you see here, if you see max worker thread, which is 640, and workers created was 698, which means you have actually exhausted all the worker threads. So this workers created also includes some of the internal workers, but all your user worker threads are exhausted in this case, which means any new connection to the SQL Server will be in a hang state and it will not complete and you will see your SQL Server hang. So again, this without any additional data collection, I can see the worker threads which are collected, and further I can try to correlate some of the information which we have captured in this system health session. If only my query responds, or if my server responds. Okay, in the interest of time, I don't want to go deep, but you can play around with it. I'll quickly show you what are the steps which you need to follow to ensure you. So I will be sharing all the scripts for this solution. The first step is you need to create the database DBA local which is present in the script. Then you need to create all the objects within the database which is also present in the script. Then you would need to create SQL agent job. So on all the SQL instance which you want to monitor, you will create the job, and the job would be like DBA hyphen load sessions DBA, and there is another system health session. Now these jobs the performance job is set to collect every 5 minutes. The session state is set to collect every 1 minute, and this is you would want to run every day. Again, I don't have a schedule there, but you can run every day, wherein all the XCL files or X event files are loaded in the DBA local database. I will also be sharing all the SSRS reports. So these are all the SSRS reports which I have. I will be sharing this. You will have to, if you're familiar with SSRS, you would know and you can open them. Else, you can open them in SQL Server Data Tools, and you can go to Properties, make sure you identify the target server name, and then once you can then deploy it without any issues. Once you deploy them, you can go to that report. When you go to the reports folder, you would see two reports. These are the baselining reports which has performance capture and DMV. This is the system health reports. You can click on any of the reports and target it towards your your server wherein you have set up the data collection. So your database name has to be db_local. It has to have all the objects and it has to have all the data in there uh, for which you want to capture. So in this case, I have data collection set up for this server. So I'm connecting to that server. And it doesn't matter where your reporting services is, but it should be in the same domain and should be able to connect to that particular server using Windows authentication. So that's important. So, and once you are able to connect, you can set the timeline, you can go through it and you can view the report, export it, set subscription, play around with it. So I will be sharing all the reports here. In the interest of time, I don't want to stretch too much and don't want to use too much of your time. But in the slide, I also have some of the examples, some of the example reports. So this is how your performance baseline report over last 6 months would look like. So this value which you see or report which you see is the trend, and then further you can click on any specific day and you can drill down to a specific hourly report wherein you would see the daily performance or hourly performance. You would see the disk read latency, write latency, latch waits, sessions request. You can click on the memory report and further see the external memory pressure, if there is any lazy writes per second, page life expectancy. In this particular scenario, you would clearly see there is an external memory pressure where available memory goes down, your total server memory goes down, and the target also follows the same trend. The lazy writer also spikes, page life expectancy goes down, so all the familiar counters which you are aware of. And session status shows you all the, these are further drill down status which tells you on that given point in time what threads were suspended, what databases they were running on, and what was the most common wait type. This is the storage report wherein you can see the storage thing. I think we already talked about it. This is the index fragmentation report which will show you, connect to any database and show you the indexes which are fragmented. This is the system health report, which if for a given point in time you can go and drill down and further see what was going on, if there is any warning sign, what is the problem there. I think we already demoed this, so I'm going through this. And thank you. So I will be sharing all of the solution as is. Again, I would not have any time for supporting this solution. So this is the GitHub location where I'll be sharing it. You can use it as is. Feel free to email me. I'll be happy to hear any feedback. If you want to add, because it's on GitHub, if you want to add new reports to it, you can fork in new thread and you can add new reports based on your scenarios if you have developed anything on top of the solution. So feel free to leverage this and grow, and you can use it as is as well. So I'm sorry, I think I went like 15-20 minutes overboard, but I hope this was useful, and any feedback is welcome. I think my Twitter handle for Tiger Team and my Twitter handle, Talk to Savjani. You can have any feedbacks or any comments in there as well. So you can, that's a way you can reach out to us.
Thank you. We have a bunch of questions, and I'm going to send them to you.
Okay.
I'm just going to kind of get some overall general ones. This works on all session or all versions of SQL 2008 R2 up. Does it? It would have to be different on 2016, I think, or at least part of it would be.
So system health reports will work starting SQL 2012 onwards.
Okay.
The performance monitor capture and the performance monitor reports and the DMB reports will work on any version of SQL Server. I think except SQL 2005, yes, because we are anyways, it's out of support and end of support. But perfmon counters and your DMB reports should work on any version of SQL Server, that is SQL 2008 R2 and above, but the system health session would work on SQL 2012 and above.
Okay. Somebody asked to bring up the link to GitHub again, and for people, there's some people asking if they're not familiar with GitHub, if you could explain that a little bit.
Yeah, so again, you can, there's a video, nice video on GitHub. I think if you look at it, it should be real quick. To make it easier, you can download it from GitHub at this point in time, and if you have developed something, just send an email to me or send me a ping over Twitter, and I'll be happy to connect with you. So if you think GitHub is really complex for you, let's not. The only thing which you can do in GitHub in that case is just download it from GitHub. That is allowed.
Enough. Okay.
Yeah. So.
Okay. Let's see. As long as we've got links, I guess that's it. I appreciate you sharing all of this, and this is a great solution. I think people will learn a lot just from going through and setting it up.
Yep.
It'll help them a lot. So anyway, thank you for your presentation, and next month we'll be having a session with Glenn Berry on August the 2nd for High Availability and Disaster Recovery 101. So sign up for that. We appreciate everyone. Thank you. Thanks for showing up. Great session.
Thanks, everyone. Bye.
Bye.